Today we're going to learn how to solve systems with matrices. Now, a matrix is just an arrangement of numbers in rows and columns. So we're going to learn how to take our system of equations, put it into a matrix, and allow our calculator to do the work for us. So here we go. So we have this system of equations, and we're going to set it up as in the coefficient matrix, which is just literally the coefficients. So it's going to go 2, 4, -5, -3, 5, 2, -5, 3, -1. The variable matrix is simply our x, y, and z. And then the solution matrix is just that, the solutions. Now notice that when we started this, all of my equations are in standard form. My x's, my y's, my z's, the equal sign, and the solutions. And then it transforms into this. So this next question just wants us to go backwards and write this matrix equation as a system of equations. So it should be pretty easy. It's 1x plus 5y plus 1z equals 2. And then 2x minus 3y plus 4z equals -7. X plus 6y minus z equals 13. So this matrix becomes this system. Now, we can use matrices to solve systems in two ways. I prefer the inverse matrices, but I know some of you may have learned how to do reduced row echelon form. So I'm going to show you both of them, and you can use either one, whichever one you're most comfortable with. But think about it. When we solve an equation like 3x equals 12, what do we do to both sides? Well, we divide both sides by 3, which gives us x equals 4. Another way to think about that is to say, well, if I have 3x equals 12, I really multiply both sides by the inverse of 3. And that's what we're going to do here. We've got our, if you look back here, we've got our coefficient matrix and our variable matrix and our solution. We're going to multiply both sides by the inverse of our coefficient matrix. And because of the nature of matrices, it matters what order we put them in. So I'm going to show you that. So if I take this system of equations, notice I've got my 6, -4, 2, 2, -2, 6, 2, 2, 2, and then my solutions. And I'm just going to enter them into a matrix on my calculator. And the way I access the matrices is I can do alpha zoom, and that brings up a menu where I can describe what kind of matrix I have. So we're just going to write a note, alpha zoom. Now, matrices are named by their rows and columns. So this first matrix is a 3 by 3. 3 rows, 3 columns. This matrix is a 3 by 1. 3 rows, 1 column. And the answer it's going to give me is a 3 by 1. So we're going to go alpha zoom, and then we're going to select our rows and columns. So on this one, I want a 3 by 3. So use your arrows and choose a 3 by 3 and go down and hit OK. And then your calculator will bring up a blank matrix for you to fill in. Now, when you enter your numbers, you need to use the arrows, the arrow sign. When entering numbers, use the arrow. That's different on different versions. So if you hit enter, it's going to just try to solve the whole thing, and we're not there yet. So let's enter our coefficient matrix. So I'm going to use arrows. 6, -4, 2, 2, -2, 6, 2, 2, 2. So once you've entered all of that, now we're going to go find the inverse button. So this inverse button on your calculator is just below the math button on the left-hand side. X to the -1 is the inverse button. So we're just going to do that. Now we're going to go back to alpha zoom, and we're going to get a 3x1 matrix because I need to enter this solution matrix. So alpha zoom, we just need to change the columns to a 1. And there it is. And now we enter -4. Remember, don't do the enter button, use the arrows. 10, -2. Now I can hit enter, and that will give me the answer. So my answer to this one is -2, -1, 2. So we have our coefficient matrix inverse times the solution matrix gives us our x, y, and z. Now the other way to do that is called reduced row echelon form. So what reduced row echelon form is going to do for us is it's going to use a series of multiplication and addition and switching rows, and it's going to give us our answer. Look, something like that. So it's going to give us one. So X is our answer. Y is this answer. Z is this answer. Now, there's a lot of algebra that goes into that. That's a whole college course. But, well, not just for this equation, but other matrix operations. But I'm going to show you how to enter it into your calculator. It's kind of like calculator magic, but the calculator does all the work for you. So we're basically going to ask our calculator to give us a 3x4 matrix this time. So still 3 rows, but we're going to do a 4th column in our matrix. And reduced row echelon form is the command called REF. So let's see where to find that. We're going to go to the button called matrix. It's a blue button right above the inverse button. So second, give us matrix. And we're going to go over to math. So let's write that down. Second, matrix, math. And now we're going to look for the REF. And I believe that is capital B. So you can arrow till you get to it, or you can just type in a B. And it's going to give you that REF, reduced row echelon form. And now we're going to ask our calculator to give us a 4x3. So we're going to go alpha zoom and say, hey, I would like a 4x3 matrix, please. And there it is. Oops, I was not a 4x3, was it? I wanted a 3x4. So the good news is I can fix that. I want a 3x4 matrix. So we're going to delete that one. Whoops, let's go over here and delete that one. And let's go back to alpha zoom and say, oops, I meant to say 3x4. And then hit OK. That looks like what I want it to look like. That's the good thing about this. You can tell when you've done it wrong. So now we're going to type in everything we have here. This time, well, you're also going to use the arrow buttons. If you do this way. So here we go. 6, -4, 2, -4. 2, -2, 6, 10. 2, 2, 2, -2. And if you have time one day, I can show you how it gets from here to there. So it did some magic. Somebody got paid a lot of money to program the calculator to do this little magic for us. So notice we got -2, -1, 2. Same answers, different method. So if you've learned about the reduced row echelon form, you can use that one. I prefer this one, but they both give us the same result. So now that you know some of this calculator magic, you can go back and practice any of your previous problems with this method. It can also work on 2x2s. You just have to tell the calculator what size matrix you want to apply the process to. All right, have fun.